Hello viewers, welcome back. In this video lecture, we are going to discuss the bimolecular elimination reactions. Before going into this topic, we should just recollect the informations whatever we learned from the SN2 reaction, SN1 reaction and E1 reactions. You see here, this is a tertiary alkyl halide is given, and so this is the nucleophile. So here this nucleophile cannot attack this carbon because this tertiary alkyl halide is highly sterically hindered. Okay, this halogen connected carbon, that is, this is the alpha carbon, that is sterically hindered. The nucleophile cannot attack this partially positive charge carbon. Okay, as a result, here the no SN2 reaction is observed, that we learned in the factors affecting the rate of SN2 reaction we discussed. Okay, in that case, so what will happen? As I told you, so this is the one VIP, and this one is a terrorist. Okay, now here there are so many bodyguards are surrounded the VIP. Okay, so like this, there are so many VIP bodyguards are surrounded the VIP. Now, so he is the VIP, the center one. Now this terrorist is not possible, it can find a difficulty to attack this or shoot this VIP because the VIP is completely surrounded by the bodyguards. Now then also, suppose his boss, the terrorist leader, he says no problem, try to shoot him. Then what will happen? So he is aiming to kill this VIP. He just triggered. The probability of the attacking, shooting this VIP is very less. At the time, some of the bodyguards, whoever is surrounded, that person will get injured. The same strategy is going to happen here. Okay, here this methyl carbon is, actually this alpha carbon is surrounded by this methyl groups, and here it is not possible to this nucleophile attack this carbon, partially positive charge carbon, that is halogen connected carbon. In that case, what will happen? The same analogy we are going to apply here. So this is not possible to attack. Now this nucleophile is going to abstract this, the beta carbon proton. Okay, this is an alpha, this is the halogen connected one is alpha carbon, the next one is the beta carbon. So it will attack this beta hydrogen, and this bond will become shifted here. Simultaneously this halogen bond will get cleaved. So finally what we will get? So we will get this carbon connected with double bond, this is CH2, and these are the CH3. Okay, now like this we will get plus H2O plus Br minus. So like this it is getting formed. You see here, because this sterically hindered carbon, it cannot attack this halogen connected carbon. Instead that this nucleophile attack this proton, and this forms this kind of elimination product. You see here there are two things we should remember. Here this is the nucleophile and this is the base. Chemically here the OH also minus charge and this also minus charge. Chemically the OH minus can be called as nucleophile, at the same time this can also be called as a base. Chemically both are same, but according to the action, if this piece is attacking the proton, then it will be called as the base. If it attacks other than the proton, if it attacks the carbon, that time this will behave as a nucleophile. Here this OH minus is behaving as a base, and it is abstracting the beta hydrogen, and it is forming a double bond, that bromine also getting cleaved. Here this rate of reaction is determined or depends on the both reactants, that is nucleophile, or else you can call it the base. Okay, here it is acting as a base, and alkyl halide. So why this reaction is called as E2 reaction. 2 stands for bimolecular and E stands for the elimination. So why this is called as bimolecular elimination reaction. And one more important point we should remember, that the stereochemistry of the beta hydrogen and the halogen group, that is a leaving group. You see this halogen and the bromine, this the degree is around 180 degree. It should be 180 degree. So this type of arrangement is necessary for the this E2 elimination. So this reaction also called as either 1,2 elimination or beta elimination. Okay, so this is the other names for the E2 reactions. So this is the stereochemistry. Now I am going to take some other products, starting material. Here the beta carbon, this is one beta carbon, and this also one beta carbon, this also one beta carbon. You see here the nature of the beta carbon and the beta hydrogen environments are different. In this case, what will happen? And I am taking here 2 different bases. Please remember that in the E1 reaction we studied the Setsov product and Hofmann product. Okay, the Setsov product is highly this which one is the this is highly substituted alkene, that is called as a Setsov product. The least substituted alkene is the Hofmann product that we learned in the E1 reaction. Here the product distribution, that is the Setsov product and the Hofmann product distribution, may vary according to the nature of the base. When you see I took this is the different cases of this is an alkyl halide. Here both the here beta carbon environment is different. This is a different beta carbon environment, and here this is another beta carbon environment. Okay, and when we took this base ethoxide, it's a strong base, but it's not a bulkier. So this is the probability can attack this proton and goes like this and form this product is always a major one. Here the Setsov product will be the major one and the Hofmann product is a minor one. But if you take the same substrate and we reacting with the bulkier base, this bulkier base will always find at the free, wherever the hydrogen is, the beta hydrogen is free, which is not sterically hindered. But here this one is sterically hindered. Okay, but here this carbon, these hydrogens are sterically hindered, but this one prefers to take which is not sterically hindered. So this, it will take this hydrogen and it will come like this and it will go like this. So finally we will get these 2 types of products. But when this is the bulkier base, we will get the Hofmann product is always the major ones. Okay, so this is how the base will decides the product distribution of this Setsov and Hofmann. I hope you understand this class. Kindly subscribe and share it if you find this lecture is useful. Thank you.